From the lighting systems perspective, we tried to set up the building to maximize the use of daylighting. And the way you do that, it's pretty straightforward. You make a narrow building so that everybody is within 20 or 30 feet of a window that is daylight. Not only do we do that, we think about the placement of the windows. We don't want to have a lot of windows on the west side of the building where the sun can produce daylight but too much heat. So we designed the building to have a long axis along the east and west, and so that we have most of the glass on the north and south of the building. Therefore, we can control the solar load and the sun. We also used high ceilings. The laboratories have very high ceilings, 12 feet. It gave a lot of flexibility for the labs, but also created great daylight in the space. The office space has 10-foot high ceilings and lots of glass judiciously placed so that the daylight comes in a even manner and allows us to dim the lighting down. Our approach on the design of this building is, let's make a net zero building, but first and foremost, let's create a great building for great science. And we didn't want to sacrifice anything as it relates to comfort and performance. In fact, we wanted to deliver a space that has better performance. And I think the daylighting is a great example of that. What happens in a lot of buildings that are being built today, the thought is, oh, daylight and views, let's just make an all glass building. Everybody can see, there's lots of daylight, it's wonderful. Well, in fact, that's very problematic. What happens with the floor to ceiling glass in these new buildings is that there's a huge amount of glare. That is, the sun's coming in, it's creating too much daylight, and people bring down the blinds so that they can see their computer screens. The other thing that happens is that when you're sitting near a window, that sun comes in, it makes you thermally uncomfortable. You're too hot, even though the air temperature might be perfect. So we took a different approach. Let's get the daylight into the building. Let's create great views, but let's do it in a way that you don't overheat when you sit next to a window and there's not too much glare. So we controlled the daylight. When you control the daylight and create better comfort in the building, it also lowers the energy consumption because we're not getting a lot of the direct sun coming in the window. Therefore, we don't have as much cooling requirement. It makes the building more efficient, but we start from this premise of let's make a better building, a building that's more comfortable, and then the other things fall into place as far as energy goes. There are some elements that are automated. The sun shading blinds come down in an automated way in the afternoon when the sun gets lower and the sun starts to shine directly in. But the users can go and override that. Same thing with the lighting. It automatically dims down based on the amount of daylight that's in the space, but you can override it if for some reason you want more or less light. The whole idea is we're going to deliver a base of amount of light in the space and then allow people to adjust to get the visual comfort, the visual accuracy that they want.